Everyone thinks they understand gravity. You step onto a scale. A number appears. That number is your weight. Simple. You drop a coin, it falls. You throw a stone, it curves downward. The moon circles the planet Ardan. Planets trace endless paths around the star Helios. Objects with mass attract each other. That's what they tell you. Centuries ago, a man named Alaric Northwind wrote equations so elegant that humanity stopped asking questions. His mathematics predicted everything people could see. Apples falling, moons orbiting, tides rising, worlds moving in silent harmony. Gravity, he said, was a force, a pull, invisible, instant, universal. And everyone believed him. But what if that idea, this comfortable, familiar idea, is not just slightly wrong? What if it is completely wrong? The push you never notice. Stand up. Right now. Feel your feet against the floor. What do you feel? Most people answer without thinking. Gravity pulling me down. But that's not what your body is telling you. What you actually feel is pressure. The floor pushing up into your feet. The ground resisting you. You have never felt gravity pulling you down. Not once in... The strangest thing about gravity is not that things fall. It's that some things fall forever and never arrive. Look up at the night sky over Valoria. There, drifting in silence, is Luma, the silver moon. It has been falling toward the planet since before the first ocean formed, before the first mountain rose, before life learned how to breathe. Billions of years of falling, and yet it has never hit the ground. What kind of pull behaves like that? A pull that never finishes the job. A pull that works endlessly, tirelessly, yet never quite succeeds. According to Alaric Northwind's law, Luma is being pulled toward Valoria every second of every day. The force is enormous. The planet is massive. The distance is vast, but not infinite. And yet, no collision. Just a perfect, eternal curve. Always falling. Never landing. Northwind's equations were flawless. Engineers used them to build bridges. Navigators used them to chart the skies. Astronomers used them to predict eclipses centuries in advance. But there was a problem Northwind himself could not solve. His gravity worked instantly. If Valoria shifted even slightly, Luma would respond immediately across hundreds of thousands of miles of empty space. No delay, no signal, no messenger. A force with no mechanism. Northwind called it remote influence. Privately, he admitted something unsettling. He had no idea how gravity actually worked, but the math worked. So people stopped asking. The man who refused to ignore. 8 minutes. Centuries earlier, before gravity had a name, before equations ruled the heavens, there lived an observer named Taran Cole. Taran did not theorize. He measured. Night after night, year after year. From a stone observatory perched above the deserts of Ashkara, he tracked the wandering lights of the sky. He mapped their positions using brass rings and sighting rods, recording angles with obsessive precision. Why such care? Because nature does not reveal itself to guesses, only to patience. When Taran died, his notebooks, thousands of pages of careful measurements, were passed to a quiet mathematician named Elias Venn. Elias believed the planets moved in perfect circles. Everyone did. Circles were divine. Circles were pure. But when Elias tested circles against Taran's data, one planet refused to cooperate. Carith, the Red Wanderer. It was off by 8 arc minutes, a tiny error. So small most scholars would have ignored it. But Elias trusted Taran more than theory. 8 arc minutes meant the idea was wrong. So Elias did something radical. He abandoned perfection. When nature chose ellipses. For years, Elias struggled. He tried circles within circles. He tried shifting centers. He tried invisible guiding spheres. Nothing worked. Until, exhausted and desperate, he tried a shape no one respected. An ellipse, 2 foci, unequal distances, imperfect symmetry, and suddenly everything aligned. Every position, every measurement, every deviation. The planets were not moving in circles. They were tracing stretched paths, with the star Helios sitting off-center at one focus. It was beautiful and disturbing, because it begged a deeper question. Why ellipses? The straight line problem. Around the same time, another thinker was playing with rolling spheres. Marin Salas was not interested in the heavens. He was obsessed with motion itself. He rolled polished stones down wooden ramps. Downward, they sped up. Onto flat surfaces, they kept moving, longer than anyone expected. What if, Marin asked, nothing stopped them? What if there were no friction, no air, no resistance? The answer changed everything. They would move forever. Same speed, same direction. Motion did not require a cause. Stopping did. This was the birth of inertia. An object moving straight, uninterrupted, was not strange. It was natural. What needed explanation was deviation, turning, slowing, curving, and that created a cosmic puzzle. If planets prefer straight lines, why do they curve? North wind's great synthesis. Alaric north wind saw the pieces come together. Planets want to move straight. That's inertia. But they curve toward Helios. Something deflects them every instant. That something he named gravity. A universal attraction. Every mass pulling every other mass. Stronger with more mass. Weaker with distance. Specifically weaker with the square of distance. With one law, everything clicked. Ellipses were no longer mysterious. Planets were falling sideways. Luma was falling toward Valoria, but moving fast enough to keep missing. Apples fell for the same reason moons orbited. Heaven and ground obeyed the same rule. It was magnificent. The perfect coincidence. Then came the detail no one could explain. Drop a hammer and a feather in a vacuum chamber. They hit the floor together. Exactly together. According to North Wind's gravity, the hammer should be pulled harder. It has more mass. But it also resists acceleration more. It has more inertia. The two effects cancel. Perfectly. Always. For every object. For every substance. To absurd precision. Why should two completely different properties, one that determines how strongly something pulls, and one that determines how stubbornly it resists motion, be identical? Northwind had no answer. He called it coincidence, the question that changed reality. A young clerk in the city of Rayon refused to accept coincidence. His name was Cale Aaron. Cale asked a simple question. What if it's not a coincidence at all? What if it's a clue? Imagine, Cale said, that you are sealed inside a windowless chamber. You feel pressed to the floor. Are you standing on Valoria? Or are you drifting in deep space inside a vessel accelerating upward? There is no experiment that can tell you. Gravity and acceleration feel identical. This was the principle of equivalence, and it shattered everything. Falling is freedom. If gravity and acceleration are the same, then maybe gravity is not a force. Maybe falling objects are not being pulled at all. Maybe they are doing nothing. Maybe they are free. The apple falling from a tree feels no force. The moon orbiting feels no force. Astronauts drifting inside a capsule feel no force. They are all in free fall, following their natural paths. So why do you feel weight? Because you are not free. The ground prevents you from falling. It pushes you upward. You are the one being accelerated. Standing still is not natural. Falling is. The curve you cannot see. Cale's insight went further. What if objects move straight unless forced otherwise, and falling objects feel no force? Then their paths must already be straight, which means space itself must be curved. Mass does not pull. Mass bends the geometry of space and time. Objects follow the straightest possible paths through that curved geometry. Near Valoria, straight points inward. Not because something pulls you, because that's how space-time is shaped. Proof written in starlight. Cale made a daring prediction. Light should bend. During the eclipse of Helios, observers measured stars near its edge. Their positions shifted. Light had curved. Space itself was bent. Gravity was geometry. What comes next? If this is true, then stars collapse not because they are pulled inward, but because space-time curves inward. Then black voids form where all paths lead down. Then ripples travel through space-time when massive bodies collide. The universe is not held together by invisible strings. It is shaped, woven, curved. Astronauts orbiting Valoria appear weightless, floating, spinning, drifting through their metal capsules. They feel no pressure on their feet, no pull on their bodies. Many call it zero gravity. But Cale Aaron would have laughed at that phrase. Gravity has not disappeared. At the altitude of these orbiting stations, the gravitational field is still nearly as strong as on the planet's surface. About 90%. What changes everything is that everything, the capsule, the astronaut, the water, the instruments is falling together, following the natural curves of space-time. The capsule is falling sideways so fast that as it drops, Valoria's surface curves away beneath it. The astronauts keep missing the planet. They are forever falling around it, never into it. Everything is falling. The motion feels weightless because there is no resistance. Free fall is freedom. Standing still, conversely, is acceleration, the ground pushing, the floor pressing, the illusion of weight. Even the apple in the orchard is in free fall. It hangs from the branch, supported, deflected from its natural path. The moment the branch breaks, that support disappears, and the apple follows the straightest possible path through the invisible curves of space-time. It falls, not because something pulls it down, but because the geometry beneath it tells it where to go. Cale Aaron realized something extraordinary. Everything near a massive object behaves this way. Mountains, oceans, trees, planets themselves all follow the curves imposed by mass. The shape of the world, the paths of moons, even the arc of thrown stones, everything emerges from geometry, not invisible force. The curve that makes a sphere. Take Valoria itself. The planet is round, a perfect smooth sphere. Many assume it is round because gravity pulls everything toward the center. But Cale Aaron saw it differently. The sphere is an emergent shape, a consequence of matter following curved spacetime. Each grain of rock, each drop of water, each drifting particle of air is seeking the straightest possible path through the curves, created by Valoria's mass. The result? A surface equidistant from the planet's center in every direction. A sphere. Not because something molds it, not because an unseen hand pushes it into shape, but because geometry compels every part of matter to arrange itself naturally. From the perspective of an ant crawling across Valoria's surface, the path seems straight, but in reality the ant is tracing the curve of spacetime, unaware that what it perceives as straight is actually a tiny segment of a sphere's surface. Time too bends. Space alone is not enough to describe the universe. The massive planet curves space and time together. This four-dimensional fabric, space-time, is what guides every motion. Planets orbit stars, stars collapse under their own weight, comets swing past suns, moons drift endlessly. All trajectories are straight in this curved geometry. Straight paths appear curved only because the canvas beneath them is bent. The fate of massive stars. Cale's insight reshaped not just planets and apples, but the destiny of the stars themselves. A star is a furnace, a massive ball of gas burning nuclear fuel in its core. Its mass creates a well, a depression in the fabric of space-time. In the end, Cale Aaron understood something simple and unsettling. What humans feel every day is not gravity itself. What they feel is always a push, the push of the ground, the chair, the floor, anything that prevents them from moving freely. Gravity is never felt. Gravity never pushes. Gravity only shapes the path. Mass bends space-time. Space-time tells matter how to move. The apple falls because it is finally free. The moon circles because its straight path has become a curve. Astronauts float because nothing resists their motion. Standing still is not rest, it is acceleration. Falling is not motion, it is freedom. Newton was not wrong. His equations still work. They guide satellites, predict eclipses, and help us navigate the sky. But Newton explained how gravity behaves. Einstein and thinkers like Cale Aaron revealed what gravity truly is. The universe is not held together by invisible strings. It is not pulled by mysterious forces across empty space. It is geometry. Silent, elegant, inevitable. The next time you step on a scale, watch something fall, or look at the moon drifting across the night sky, remember this. You are not feeling a downward pull. You are being held back from the path the universe has already drawn for you. And that path, quiet, curved, and unseen, is what we call gravity.